G'day guys, welcome to the second video in this series. Today we're going to work out how to do some pathfinding. So you see we've done some different terrain. We've got our nice grasslands, our lowlands here, and the idea is the darker areas as you go up the mountain. So what I'm going to do first is try and make a pathfinding, which will find it really easy to walk on the grass, and as you get higher it'll be a bit slower and more difficult, which means if you wanted to walk from say up here in the top left to the bottom right, rather than walking a direct line straight across, our little guy's going to want to walk through the nicer areas. Maybe he'll cut across here, but he'll stick to the easier to walk areas. And we'll put in some actual barriers and walls and trees and things later. But what we're going to do is actually, every little square is going to have a cost. And the pathfinding will look at the cost of each one and use that to work out the best way to get there. Now the good thing is about Godot, the pathfinding is all built in. I thought when I came into this I was going to have to write my own A-star algorithm, which is a really common pathfinding algorithm, which is what's built into this one, but it's already built in, so we're not going to have to do it. So here's how we're going to go about it. So I'm just going to make a little child node here, and it's just got to be any kind of node to make it the base class node, and we're going to call it pathfinding, and this is just going to hold all our pathfinding scripts. So let's add a script to that, call it pathfinding. The first thing I'm going to do is give this access to our terrain. So on ready, var terrain, and our terrain, we just drag it from over here. So now we've got this variable terrain which we can refer to, which will talk directly to our terrain, so the pathfinding can actually find out what the terrain's like that we're walking over. And what we need to do is actually have a reference to the A-star grid class. So it's var, I'm going to call it A-star grid. And we'll just refer to this. You've got A-star 2D, 3D, and grid. We're making a nice simple grid-based game, so we're using the A-star grid 2D. The other ones work pretty similarly, but let's use the one that works for us. So let's make a new instance of that. And I'm going to make just a little variable here to hold our path after we make it. Now the path is just going to be an array of vector 2D, so a little array of positions. So an empty array there. So the first thing we need to do is initialize our pathfinding, which means we've got to let the pathfinding have access to our terrain and know what it's actually doing. So we just have to, first of all, tell it how big it's going to be. So A-star grid, set the region size, and we'll set it by a rectangle. So position doesn't matter because we're just telling it the size. And we're just going to grab our terrain.mapWidth and our terrain.mapHeight, which that's referencing the height and width of our terrain. Now we need to tell it how big our actual cells are. So our cell is one unit of our one little grid there. So for this, they're 16 pixels each, which is what we made them. So let's go back to pathfinding. Oops, pathfinding in the script, and we just go A-star grid cell size. There's a vector 2, 16 by 16. So you can actually have, rectangular grids, and then we'll just update that. And the final thing we need to do is a loop through every single, did I do that? Yeah. The final thing we need to do is loop through every single position and tell it what's in there. Now it doesn't need to know if it's grass, mountain, rock, whatever, but it needs to know how difficult that spot's going to be. So we have to add that difficulty now. And the way we do that is with custom data on our tile set. So go down to tile set and click one of these guys. And you've got the coordinates, animation. We want to go over to the right and you've got your custom data layers. And we're going to add an element and we're going to call it, let's call it cost. No, let's call it difficulty. So it's easier for us. We could even, let's make it really obvious, walk difficulty. And its type is going to be a float. So what it's going to be is higher numbers. It's going to be a higher cost, and we'll use that little number to multiply our walk speed as well. So if it's a really easy walk, we'll walk fast, but if you're walking this one, it'll be slower, slower, slower. Now if you go down here, you've got custom data now. And what we need to do is for each type of terrain, we need to click on that. And so let's make our grass 1, just standard. This one, we're going to make it a bit more difficult, 1.2. Let's make the ground 1.5. Let's make the rocks a bit harder. Let's make it 3. And then the snow, let's make it really hard. Let's make it 8. So like everything we do here, these things you can come back and fiddle with later. And you might want to have different terrain types. You can even have, you could have cement, a bunch of other ones. You could have a road, which might be 0.8. But this will allow us to get started and we can tweak things from there and make it prettier. So now that that custom data is there, we can go back to our script and we're going to loop through every single point in the grid. For x in range, terrain, map width, for y in range, terrain.map height. Now getting access to that custom data is actually a pain in the butt, and it takes a few lines of code. So I'm not going to write it directly in here. I'm going to go down the bottom and I'm going to make an extra little script to grab that difficulty. And I'll show you what I mean in a second. So I'm going to make a function called get terrain difficulty. Whoops. Get terrain difficulty. And we'll just add the coordinates in it. And we're going to set the layer equals 0. And we've got to get the ID of the cell. Terrain.get cell source ID. Source is going to be of the type tile set atlas source. Then we're going to grab the atlas coordinates, which is what we got here. That's 0, 0, 0, 1, 0, 2, sorry, 0, 0, 1, 0, 2, 0. It's the position in our atlas. And now finally, with all that, we can grab the data. So we have tile data equals source, get tile data. We give it the coordinates, and the data we want is number 0. So you can put in a bunch of different data points here. We want the first one, which is the 0th one. And then we'll return the tile data, get custom data, and now we give it the actual name of it. And I just realized I've written date there instead of data. Sorry, and I called it walk difficulty. Oh my gosh. Walk difficulty. All right, let's see if that worked. What I'll get it to do is I'll loop through every single one and I'll just print get terrain difficulty for vector 2i xy. So what this should do is loop through every single square and just print the difficulty. So we should get a list of 1s, 1.2s, 1.5s, 3s, and 8s. And that'll run on start. So let's just go to output. Let's run it and see if she works. Nice. Yeah, that's definitely what we want. All right. So all we need to do now is, instead of printing that, we're going to pass it into the A star grid. So that's the data that A star grid will work from. So what we do is we just go A star grid, set point weight scale. And we tell it the coordinates, which is vector 2i xy. And then we pass it the difficulty. XY. And that's it. That's all our grid needs to know. We don't have any walls or impassable places yet, so we just need to, we can put in impassable ones by going a star grid.set point solid and give it the vector 2i. So if you did that, that would actually make all of them impassable. So we're going to just leave that there for later because we'll definitely use that for something. All right, so that will settle that. And now what we need to do is actually build a path. And just to test, what we'll do is we'll set a start. And let's make it vector 2i. Let's just make it 0, 0 to start off with. An end. And let's just make it 78, 23, just something random. I just realized that should be vector 2i. And now we just request the path. So we go path. If you recall, path is our variable up here. Equals, and we just go a star grid dot get point path from start to end. And that's it. That's literally all we have to do. We've set up our grid and requested a path, and we should get it. And just to see if we've got it, we will draw it. So this is optional, but it'll help us test things. So we just go function, draw, and we'll just go if length of path is greater than 0. So basically if there's any path whatsoever, then we'll loop through the path. And we'll just draw a line from path number I to path number I plus 1. I just realized we don't want to go through the whole thing. We need to go -1. Oh, I forgot to tell it what color to be. Let's make it purple. Oh, and I just realized, of course, I can't run drawLine because that's not built into the basic node. That only works off a node 2D. So let's just quickly change this to a node 2D. So I'm just going to grab all this, copy it. Let's delete pathfinding. Delete that node. Let's make a new one, and let's make it a node 2D. Silly me. Node 2D. Call it pathfinding. Attach a script, call it pathfinding. Basically, we're just going to change that one to that, or you can paste in the old one, which has node 2D, and save it. There, let's see if that's going to work. And there we've got a line. We can't really see where it's coming from and going to, so let's just fix our camera to something a bit better. So right now we're just seeing that square there. Let's zoom out and see the whole thing. So I'm just going to add a camera here, add child node, camera 2D, and let's shift it down here, zoom it right out. There we go. You see we've got a path from 0, 0 to over there. What did I say it was? To 78, 23. All right, let's fix it up so we can test it right here in the editor. So what we're going to do is, as we did last time, make this into a tool. Rather than doing this on ready, let's break it out into a function. So def init pathfinding. So all the initialization stuff we'll steal from there. Sorry, def, different language, func. Now the start and end, let's put them in here. Var start equals, actually let's say, and var end. And let's export those so that we get them in the editor, the inspector I should say. And let's make a button. We'll calculate, and that'll be a bool. And so when we click that, that'll tell it to go and compute for us. So in process, let's just go if calculate equals false, and then we will find a path. So let's make that find path, and that's where we just go. This one, let's delete those guys. Oops, no, pass. Oops, that's about calculate wrong. And since I've just turned this into a tool, before it'll work, I have to actually go and reload the current project. So let's do that now. Okay, so if I grab my pathfinding, now I've got a start, an end, and a calculate. So let's see. Let's make it start at 5, 5, finish at 64, 64. When I press calculate, you can see it's going automatically turning off. So the button's working. It is actually doing our path, but it's not drawing it for us. So what we need to do is go back and make sure it actually, so the draw function is still there. It's still going to draw the path, but nothing is telling it to call again. So we need to tell it to. So what we'll do is after we find a path, we'll just go Q, redraw, and that will tell Godot that it needs to run draw again, at least in its next draw pass. So when I press calculate now, oh, why isn't that working? Let's make sure it's actually drawing. Oh. Can't get ID path, 0.5 out of 5 out of bounds. 5 out of 5 is out of bounds. Oh, I know. I'm not actually calling initiate pathfinding. There we go. So now, all right, I think the problem is I'm running in the editor, so it's not actually calling this one. So what I'll do for now, let's just add that to the button as well. It's a terrible slow way to do it. But for playing around in the editor, for now it's fine. So now I press calculate, and there we go. And let's change that to over there. And you can see, to get to here, it's actually gone around the mountain. If we go up a little bit, or across a little bit, now it goes the other way. Let's move this guy down. And you can see, because of the cost of walking through these white and grey tiles, it's gone all the way around. So that's pathfinding, it's working. We're giving it a start, we're giving it an end, it's finding the way. So that's all we really need for now. Let's add in a character and make him follow it. So the first thing I'm going to do, because I'm going to go and make a pawn, I want to stop calling this one node TD, and this one's just going to be our game. So that's going to be saved as game. Make sure that's game. So now we're going to go and make a new one. So let's go scene, new scene, and the type is going to be a character body type 2D. And the character body type is great because it's got a bunch of built-in moving stuff, built-in character controller stuff to make it easy to move. So I'm just going to call this guy a pawn. He's going to need to have a, what's it called, a sprite 2D, just to hold his little picture. And I've just grabbed a little picture for him. So I'm just going to go to texture, quick load, and I've got this little character sprite here that I like to use. This is actually an old icon from, what's that, some Golden Axe, an old Sega game. So obviously we can't use that in a production game, but this is just us mucking around. This is just our programmer art. So I'll put him in for now. And when we get it, if we take this game any further, I'll get an artist to come and help me out with that because I cannot draw for shit. Now let's add a script to this guy. So it's going to be our pawn. And you see by default, it's got a bunch of stuff like his movement speed, jump velocity. It's got gravity in there. So if you're not on the floor, we can fall down. If you press spacebar, it'll jump. So it's built for like a platforming 2D game. So we're not going to use any of this stuff. So I'm going to keep this one here. Because what this is, if you press the action UI accept, which is a spacebar, then we can do something. I'll use that in a minute. This is for moving left and right. We're not going to use that. but you do want to have move and slide. So that's a built-in part of the character model 2D. Once we set his velocity, it'll apply that when you run this one. If you don't have that, he's not going to move. Oh, and we get rid of the gravity and get rid of the jump velocity, but let's keep speed for now. Yeah, we call this guy pawn. All right, and let's go ahead and go back to our game, and I'm going to put a pawn in right now. Oh, that's right, it needs to have a shape. So let's go back and let's give him a collision shape 2D. And let's make his shape a capsule. There we go. Now when we go back to our game, we can go see our little guy. And I want to make sure that he's the size of one of these little squares. So you see he's too big right now. So what I'm going to do is go back to here. And what I'll do is just change the size of this. So I think that's right. Let's go have a look. No, it's still a bit too big. When I make the final game, of course, you'd make him the actual right amount of pixels to fit in here. Oh, that's about right, I think. Let's make him a bit smaller. A little bit too small. All right, and let's make his collision shape match. All right, so what I'm going to do, I'm going to tell this guy that when I right click here or left click, I think I'll do left click, it will talk to the pathfinding class and it'll ask it for a path from here to here, then he'll get it back and he'll start walking it. First, I'm going to make it so I can actually click and it'll find that direction. So let's do it. First of all, I need to actually add that. Let's go project settings, input map, and I've already added here. So what we do is we add a new action and I'm just going to call it click for now. It'd be a good idea to call it what it is, like move or something like that. But for now, let's just call it click and I can come back later. So add that. And then we attach that to a button. And the button we're going to add it to is a mouse button. Yeah, left mouse button for now. So that action click is associated with the left mouse button. So now in my pawn script, when I say is the action pressed, click, let's just print clicked. And there we go, that's working. All right, so what we're going to do now is I want to get his position. And the way we get that is we go position. But there's a problem. This will give his position in pixels from here to there. So if he's, whoops. And the problem with that is we want this to be 0, 0, this to be 1, 0. But that's actually going to be, instead of being 1, it's going to be 16. Because every square is 16 pixels wide. So we just need to account for that. So if he's sort of not exactly in the middle, we'll try and round that off. So the game thinks he's here. Because the game's pathfinding is going to work off that grid. And all we need to do is just divide his position by 16. But let's make it more programmatic because I've got these 16s written everywhere. What we can actually do is go to the part in the game where that is defined. And that's in the terrain. And it's the rendering quadrant size. Now I haven't got the terrain in here yet, so let's add that. There we go, so that will give us his current position. And the position we want to go to, so it's the target position. And we just go get global mouse position. So that will give us the position here, but it won't give it to us from the screen position. It'll give us the actual world position. So Godot makes this stuff really easy for us. And once again, because we want to change it to our coordinate system, we're going to divide that by 16, or by the rendering quadrant size. And so now we just need access to the pathfinding. And we'll record his path here. And so we'll just go path equals pathfinding dot request path from his position to the target position. And let's just go and make this method. So we've got find path, but I don't really like that. Let's call it request path, and then we'll just return that path. Whoops. And we're going to change that old one back to here, so it will still work in the editor. So what it'll do now, it'll still get that same path, which I need to pass that information through. What did we call it? We called it, well, it doesn't matter, let's just call it start is a vector 2i, and end is a vector 2i. So it'll do the same thing now. It'll grab that path, it'll draw it here on the editor so that we can still see where it's going for now. Then it will return the path to our pawn. And he's going to know his path. And then here's what we do. We're going to have his actual walking now. And we're just going to go if the length of his path is greater than 0. So if there's anything in there, right now there's 0 in there, so he won't try and walk. Then we need to get the direction to the first point in that path. So direction, we're going to get the global position, and that gives us the global position of our guy, no matter where he is. It's not going to give us the screen position, but the number of pixels from the 0, just like our global mouse position. And we get the direction, direction to path number 0. So you can see Godot makes this stuff so easy for us, it's ridiculous. And velocity is a vector 2, which is what gets passed to move and slide to make him move. So our velocity is just going to be our direction, and we'll multiply it by his speed. And mate, that's it. All we're going to do now is when he gets to that first point, he's just going to stay there. So we need to make it so when he gets close to that point, we delete it, so then he can go to the next one. And the way we get the distance is if position.distance to path number 0, and let's say if it's less than our speed times delta. Now the reason we have that is because our speed is 300. We don't want to go by 300 pixels, but what happens is every time this one goes and clicks once, it gets divided by this delta, or this delta is giving us what it's divided by. So basically if we're going 60 times a second, that's going to be 0.02. And so this is actually how much of our speed we'll have every tick, which is what we want to go from. And then we'll just go path, remove at position 0. So that will move the 0th position. What have I done wrong there? Whoops. That's it. So if we get when we get close, it'll remove that position from the path, and then the second point will become the 0th one. So then we'll start walking towards that one. And one more thing we need to do. So our else, so if there's nothing left in the path, our velocity is going to become vector 2, 0, 0. So we're just going to stop. All right. So we click. That'll request the path. When we've got a path, we're going to walk. I think we're good. Let's try it. So our little guy's there, a bit hard to see. Let me click here. We've got the path, and we can see him walking along. This is probably hard for you guys to see. It's even hard for me to see, so let's make the screen a bit bigger. So project settings, general, the window size, and let's make it 1980 by 1020. Huh, that didn't help much. Let's go zoom this camera in a bit. So there's our guy. And my friends, we have pathfinding. Now if we force him to go here, you'll see he will do it. But he'll always find the quickest way. Well, not the quickest, well, yeah, sort of the quickest way. But he'll calculate, and you see he'll always go around those big mountains if he can. All right, while we're here, why don't we actually change his speed as he walks over this land, so it does actually cause some cost. So all we need to do that is go back to our pawn. And here, when we're doing his velocity, I'm just going to multiply that by pathfinding.get terrain difficulty. So that's our little method we made here, which will get the walk difficulty of the position. And we're going to get the walk difficulty of the position underneath him. And the way we do that, we just grow position divided by terrain.rendering quadrant size, so to get our 16. And we're actually going to not put in that number directly, we're going to divide that number by 1. And in fact, that's getting really long. Why don't we grab this massive thing here? There we go. So if the difficulty is 1, that's 1 divided by 1, it'll be 1. Or if it's 2, it'll be 1 divided by 2, that'll be 0.5. So now we'll be dividing his speed by a half, or multiplying it by a half. And let's see how that works. So walking across the green is pretty quick. Dark green's still pretty good, but you'll see as we get into these darker ones, he starts to walk quite slow. And you can see on the snow, he walks super slow. There we go. So now it actually means something. There's a reason for him to walk around and find the best path, because it does actually cost him to walk on the higher land or the more difficult to walk land. Okay, so before we finish up, I was going to show you how to add in objects like trees and rocks on another layer and have that work with the pathfinding as well. But we've been running a bit long, so what I'll do is I'll just quickly show you how to make something completely impassable, and we'll do it for this white snowy areas. So what you do is you go back to your tile set and you grab the one you want, and we're going to set the custom data, and I'm going to make let's make it -1, and -1 will be my little signifier that is impassable. So we'll go back to our scripts. And if you recall, I've got this little script here which sets a point to solid, which makes basically the pathfinding will ignore it altogether. If if get terrain difficulty of vector to I, X, Y equals -1. Now I'll put in way too many parentheses here. Let's fix that up. The parenthesis. Yeah, then what we'll do is we'll set that position to be solid, or else we'll treat it as normal. Now what have I done wrong? Oops. Alright, so if the terrain difficulty is -1, we'll set that point solid. Let's test it out. Now you can see when we walk, I can't even click on this area at all. It's not part of the pathfinding at all anymore. And even if I take, let's try and walk from here to here, something that should definitely take a path through there, it's going to walk all the way around because simply those squares are not included in the pathfinding. And you see we've got a little bug there as well. And that is caused, if you look closely, you can see we're actually not drawing lines to the middles of squares. Let me zoom in and show you what I mean. We're actually always drawing our lines to those top left corners. Now that's actually a bug because we want to treat the middle of the square as our square. So let's quickly fix that. It's really easy. All we need to do is after we generate our path, we're going to loop through that path for I in range length of our path. Path I, we're just going to add to it vector 2, and basically we're going to add half of a square to it. Now let's do this the programmatic way. Let's go terrain dot, what was it? Rendering quadrant size. And of course divide by 2, so we're getting halfway through those squares. Let's give that a try. And there you go, now we're going to the middle of our squares. Alright guys, I think that's enough for today. We've got our little guys running around now. Now of course once we've got that, it doesn't have to be us manually clicking him, telling him to move somewhere. It's going to be a Rimworld style game. So the character will have his own little needs and wants and little priorities. And so when he thinks he wants to go eat some food, he'll find some food on the map. And if there's food over here, he'll go and find his way to it. So this is a big bedrock of our game here. And now that we've got it, we can go and build from there. All right, thanks guys. I've taken enough of your time for today. Have a good one. I'll see you next time.